Okay, welcome back to the course. We're talking about section 4 here, adding enemies, and specifically in this video, we're going to talk about creating enemies with abilities. So let's head over to Unity and get started on that. Okay, so before we start with the enemies, we're going to need to be able to interact with the enemies and the environment, which is not something we can currently do. So I want to go ahead and fix that real quickly right now. So to show you what I mean, let's go ahead and hit play mode. And then you'll see that I can move around. But I go straight through the environment. That's because collisions are not happening. I'm just translating this object and not accounting for collisions or physics in any way. Same thing when I fire my bullets. Those do actually use physics, as you'll see. But they kind of just bounce off the environment and don't do much. What I want them to do is have some sort of effect when they hit the environment, or to disappear, or to do something. In order to do that, let's start with our movement. So let me exit play mode. Go ahead and start by adding a rigid body to our player actor. And I'll explain why and what we're using this for in just a second. So let's go into our sample character controller. And then inside of our character controller, let's go ahead and add a field for that rigid body so we can do something with it. Okay, so I have my rigid body set up here. And I could make it a serializable field and assign it via the inspector, but another thing we can do is just use GetComponent. So I'll show you how that works here. And GetComponent is a generic method, meaning you can specify the type that it's going to work on. And because we want rigid body, we pass the type rigid body to it here in the type. And that's just going to return the first component that it finds. In this case, our actor only has the one that we added to it, so this will work just fine. But if you want more finite control over it, then you can just more sort of assign this reference more directly, either through the inspector or through some other means. But this is a quick and dirty way to get it done, and it'll work for our purposes. So I'm going to go ahead and save. And then one last thing I want to be able to do is modify how we're doing our movement. So I've added a line here for using velocity instead of translate. So I'm going to comment out the line where I do translate. And I'm going to uncomment the line where I use the velocity. So all we're doing here is now that I have a reference to the rigid body, I can access its velocity component, which is just a vector 3. It is something that we already have because we have the input vector 3. And so I assign it input and I multiply it by the character data template movement speed here inside of the data. And so it's very similar to what we're doing before. I don't need to smooth it by delta time because velocity already accounts for time. So it's movement over time. And so you don't have to count for time here or an increment. You just sort of assign the velocity and it's going to move by that velocity every frame. So I've got my input, I've got my movement speed. Let's save this and then let's go to Unity and see what happens. Okay, so I hit play here and I'm back in my scene. You can see I can turn around and let's see if I can move. Sure enough, I can move around and I can collide with stuff. So you see collisions work as intended now. Next thing is let's fix how our bullets work. So I could just add a simple one-of script for this, but I'm going to show you how to do this a little bit more cleanly. So I created a couple scripts here that I want to show you. And one of them is inside this new section here that I created called physics. And we have a collision enter handler and a collision exit handler. So let's take a look at enter handler first. And it's an interface and it's declaring one method signature here, which is handle, and it's going to handle the event when you enter the collision. So there's two things that we pass in. One is the instigator, that's the object that began the collision. And the other thing is a collision object. Collision object is a Unity object that will contain some information about it, contact points, and I can get the game object of the other thing that I collided with. This is just a nice and clean way to do it. And then the other script I'm going to show you is the collision exit handler. So let me open that. Same thing here, collision exit handler. We're not actually using this in the example, but you'll see why this is helpful in just a moment. Okay, so the next thing is how are we using these interfaces? So let me open up this projectile test script. And you'll see that it implements its mono behavior, but it also implements this collision handler. So what I'm saying here is that I have a handle method, which takes an instigator and it takes a collision. And it should log out and it'll tell you the name of the instigator. So let's go ahead and add that to our game object. And we're going to add it to our projectile. I've added the pistol projectile collider handler here so you can see how I'm using the interface that I implemented previously. So what I have here is a script that will use Unity's event, which is on collision enter. This is called by anything that has a physics collision event. And what I've done here is I've created a list of handlers that I can then go and call handle on. So whenever this happens, anything that has a handle event here is going to be able to be called. So I'm going to run through the entire list. I'm going to call the handle on it, passing this game object and collision. So let's see if it works. And it also should destroy the game object. Two things should happen if this works. One is it should destroy the game object. And if I go back to my projectile test, I should also get the ouch, I was hit by debug log. So let's see what happens. We're going to hit play and shoot. And sure enough, I see the log here. Ouch, I was hit by a projectile. Projectile is the name of the game object. And sure enough, the bullets disappear when they hit. So they're being destroyed. And I can verify that here in the inspector, no projectiles exist. Obviously, if they go off into the distance, they'll eventually destroy themselves using the original functionality we built for the projectile. Okay, so we've handled the collisions, and now we can get into the enemies. So let's do that next. Okay, so for the enemies, we can open up this scene I created called Enemy Sandbox. Let's go ahead and save the scene, that's fine. And then you'll notice the scene looks very, very similar to the previous one, except that I have a couple things here. One is an enemy, and this enemy is just a cube, and it's got a couple things on it. It's got a Nav Mesh Agent, and it's got a couple scripts. And this is an old one, Dive Bomber. I'll show you how that works. And then there's Basic Enemy, which is sort of the cleaned up version of that. But before we go on, let's talk about how we're going to move this agent around, or move this enemy around. So we're going to use Unity's navigation system. In order to use Unity's navigation system, you have to be able to build a nav mesh, and that's super easy. Unity handles all of the heavy lifting for you. So the way you do that is you go to Window, and you open up the navigation window. And you'll see here that I've already pre-baked it in this scene, but this navigation mesh basically tells the agent where it can walk. What are the areas that are available to it? And these sort of objects are linked together so it can create a path between these different geometries that you can walk through. Okay, so the way you do it is that you won't be able to bake it unless you select the level, go back to the inspector, and make sure that it's marked as static. So if it's marked as static, specifically for navigation, then Unity will be able to bake a nav mesh onto it. So then all you would have to do is go to Bake and select Bake, and it'll bake for you. Now, in order for something to use this nav mesh, you have to add a Nav Mesh Agent component to it. So you'll see that our enemy, our cube here, has a Nav Mesh Agent component. So let's talk about how that works. Okay, so how does this Nav Mesh Agent work? So essentially I can give it a path and it will automatically figure everything else out for me. In this case, I don't have to touch any of the basic functionality on here. What we have, the default Unity functionality that come with it are exactly what we want. So we don't have to mess with that. So let me show you how this actually works. Let's open up the basic enemy script. And you'll notice a few things here. For starters, it's a basic mono behavior. We're not inheriting anything, so we're building this object up through composition. We're adding different things to it that give it additional functionality. So I've declared a few things here. An eye movement behavior, and it's just movement behavior. A dictionary that takes an action condition, and an enemy ability, and I'll talk about that later on. And then our Nav Mesh Agent, and our game object, which is the player. So in Awake, I do a few things. I set the agent equals Getcomponent.NavMeshAgent. And then I assign my player using GameObject.find with tag, and I've given the player the tag player so it can find it. And then I initialize some of my stuff here, so I create a new movement behavior here. Remember, it's looking for this interface here, and I'm assigning roam behavior to it. So let's start by looking at the eye movement behavior. Eye movement behavior has this set next target position, and that's all it does. And you notice I have it inside the enemy AI namespace. And then this concrete type, the real implementation of it, the roam behavior, does something sort of interesting here. It takes two things. It takes the agent and a number of some sort here. So let's see what it does. Okay, so this implements the eye movement behavior. So it has the set next target position method here implemented. And it takes a couple things here. There's an agent, there's a target position, and there's a roaming range. The constructor here just assigns these values. And then you'll see that the transform position of the agent plus some random range equal to this value that we passed in, and then some random range on the z. So again, remember, x is the width and z is the height. So we're randomly finding a position relative to the agent's current position, and then we're setting the destination. So set destination is a method of the Nav Mesh Agent, and if you give it a position as a vector 3, it's just going to find its way there, and it's just going to kind of work. So let's prove it out. Let's see that this is actually working, but first let's go back to the enemy class here. So new movement behavior, roam is assigned, but we actually have to set it in update. So what we do here is we check if the agent has a path or doesn't have a path, then we set its next target position. Otherwise we move on to the rest of the code. So before we get into that code, let's look at the movement and see how it works. So I'm going to go ahead and hit play here. And you'll notice some movement happening here. and see the enemy is actually moving around. And you can disregard these errors for now. I just have to assign from our previous video. This is looking for a rigid body, which it doesn't have, so I shall add that after. If you take a look at our enemy here, it's moving around, it's roaming, it's finding, path. It's staying within the confines of the level. It's picking locations that are available to it. Everything seems to be working correctly. Okay,